Alright guys, welcome back to another HackTheBox starting point track walkthrough video. In today's video, we are going to be attacking the machine Unified. Now, Unified, in my opinion, is going to be one of the more difficult boxes that's actually in any of the starting point tracks that are on HackTheBox, and that's because of the lack of information that is given prior to attacking the box. And then additionally, we also don't necessarily have the tools pre-installed in Kali that are necessary to exploit the recommended path for the machine. Now, this video could end up being 55 minutes to an hour if I went through and showed you guys exactly my process of identifying which exploit this machine is vulnerable to. But instead of creating a video where I show you my entire process of identifying the exploit, what I wanted to do instead was use this video to show you the way to get from point A to point B, or the start line all the way through the local privilege escalation for this box, because I think that also has a lot of utility. And while we do that, additionally, I'm going to take a chance to explain all of the technologies that are working at play here, and we're going to do a little bit of a deep dive into the actual exploit that is the entry point for this machine. And spoiler alert, that exploit is going to be log4j. So we're going to take a chance to look at just a little bit of how Java works, the actual interaction that the log4j exploit itself has with expression language, and then also LDAP to make operating system based authentication just with whatever third-party app wants to use it. Now, before we get started on the actual walkthrough, we have some very important business to take care of, and that is a super awesome wardrobe change. All jokes aside, let's hop right into the video. Alright, so now that we are over in the virtual machine, let's just jump into setting up for this HackTheBox machine real quick. So all that we'll do is we're just going to make a directory called Unified real quick like that, and then we're going to do and we'll cd into the directory that we're creating. We'll get rid of this. I'm going to blow this up so you guys see this a little bit better. Now that we're here, we're going to go ahead and we're going to kick off a full port scan of this machine. In my last video, you'd see us optimizing our Nmap scans with a quicker one of the top ports so we can do some manual enumeration. But like I said previously, we're just going to be going through the solutions for this box and then explaining the technologies. So to get through that a little bit quicker, we're just going to run a full port scan, and then I'm going to cut over to when this full port scan is done. However, to set that full port scan up, we're going to run sudo nmap and then lowercase s capital V capital C. We're going to go T4 dash capital P lowercase n dash dash open to specify open ports, and then we're going to do dash p dash, and then we just need to grab our IP address of the target machine, which we can do by copying that. And then if we come back over to the virtual machine, we can just simply paste that in, and then we're just going to do dash lowercase o capital N and then /full scan, just to name that scan full scan. And then we're going to go ahead and run this, and I will jump back with you guys in 1 minute when this scan is done running. Okay, so our scan is done running here. We can jump up to the top, and I'm just going to quickly iterate over everything that we're seeing here, just so you can get a little bit of my thought process, but then also we don't want to be wasting a bunch of time going down rabbit holes. So SSH is open. SSH is never usually your first attack vector, so we're going to disregard that. Second port that's open is 8080, which is typically associated with web servers. And there's some type of web proxy listening on this host, which is definitely interesting, and we want to make sure that we're checking out that website there. We do see that there is a 404 error when trying to request this web page. We'll just quickly keep going down. I do want to note the location header here so that we have a 302, which means that the resource was found, and it looks like it's a management interface, but it's only found when the location is noted as localhost over 8080. So that is definitely good to know. That's a potential bypass there that we can look into. Keep moving down the list here. I do see 8443, which is a non-standard port that's open. I do see Nagios NSCA. Not 100% sure what that is, but it does look like it's going to be another interface for this web server. If you had your web app pen testing hat on, you might see this redirect parameter, which could lead to parameter-based redirection, which would be a bug if you're participating in bug bounty programs. For the sake of this video, this is basically going to be irrelevant. We can't do a ton that's going to give us access to the machine with a parameter-based redirection, but it is good to know that it looks like this login page is using this redirect to point us back to the manage page. So it looks like we won't be able to access the manage page unless we are on localhost, or if we try to log in and we have a successful login, it looks like it's going to point us back to this management page. Now, I keep seeing Unify Network up on a couple of these, and I'm not 100% positive what that is off the top of my head, but it looks like it's some interface for this Unify software, some management interface for this Unify software. So what we can do is go ahead and check that out in a web browser. We also have a bunch of junk here right now, but that doesn't really concern us at the moment. So what we'll do is we'll just close down that terminal, and then we will open up our Chromium tab or Firefox, whatever you have, and then we're going to navigate to the endpoint of the target machine. So we do need to specify 8443. So we're going to do IP address :8443 because we want to access that management interface that was using a web server. So we will enter that, and we will get this message saying that this host needs to be accessed over HTTPS, which makes sense because we did specify HTTP, so we will do HTTPS, and then going forward, we do get what appears to be this management interface login panel. And I do see that we have this Unify logo here once again, and we also have this version number listed at the bottom. So one thing that I like to do whenever I see a software login interface in combination with a version number is we can look for publicly available exploits for this service. You never know, maybe since we do need a username and a password, there might be an authentication bypass that's associated with this particular software. So if we just open another tab here and do Unify and then paste that in there, and then we type in exploits or pen testing or CVE sometimes works, we can see if there's anything that's publicly available as an exploit associated with this software. And we looks like we do have quite a bit, and it's all saying log4j. And the fact that the first 6-7 results are all saying something about log4j associated with 6.4.54, which is what we were running, probably means that this is going to be vulnerable to log4j. So that is definitely something to pay attention to and that we want to look into a little bit further. And with that in mind, to actually exploit log4j, we need to look for potential injection points. And if you're not familiar with log4j, don't freak out just yet, because we will dig deep into that and break down exactly how that exploit works. But essentially all you need to know right now is that we need somewhere to inject the payload in. And right now, I do see 2 input fields that are making great candidates, and we have a remember me functionality, which is also probably sending data, as well as any of the cookies in the HTTP headers, and, any non-standard headers themselves that we might be able to inject into. So if we close down, or not necessarily close down, but just minimize our Chromium tab for 1 second, what we want to do to inspect the HTTP traffic a little bit deeper is open up Burp Suite. And if you're not familiar with Burp Suite, I would highly recommend you go take the web proxy class on HackTheBox Academy. They do a great job. There's some Try Hack Me rooms that also break down Burp Suite. But for the sake of this video, I'm going to assume that you know how to use Burp Suite at least a little bit. I'm going to explain this in a way that you can still follow along if you don't know Burp Suite. But to actually understand what's happening here, I would highly recommend you go and really understand Burp Suite before you continue watching the rest of this video. So, to actually send traffic and capture it, we need to enable our browser to use Burp Suite as a proxy. Quick note before we go any further, if you don't have Burp Suite completely configured in your virtual machine, just like I don't here, you will get this pop-up error if you submit a request with your proxy enabled. All that you need to do is go to the advanced and then proceed, and it will send all of the traffic through, and we will have everything that we need back in this tab. If you don't want to deal with having that pop up every single time, what you can quickly do is you can go to http:// and then burp. And when you get this pop up, you're just going to click on this certificate and it's going to download this certificate, which is totally fine for now. What we want to do is see where that is at. That's going to be in my downloads folder, but we can get rid of that. And then all we need to do, if you're using Chromium, you'll follow the same exact steps. If it's Firefox, you can do something very similar. You'll just look for certs or certificates. We're going to click on security, and then we're going to come down to manage certificates. And then we're going to come over to this authority tabs within manage certificates. We want to click on this import button and then go to downloads. And then within downloads, you're going to see this is set to base 64 encoded chains. We want to hover down to dir encoded binary. And then we want to click on that file that we downloaded, click select. And then this is very important. We want to make sure that trust this for identifying websites is selected. These two don't necessarily matter. If you click them, you'll probably run into less problems, but we will just go ahead and select all those and then click OK. And now every single time that you make a request over HTTPS with your Burp proxy enabled, you won't have to deal with that annoying advanced pop-up. Okay, now coming back over to Burp Suite, now that we have that all set up within Burp there, if you look at your intercept, you want to, make sure that your intercept is off. If your request was hanging around, that's because you had your intercept on. You want to turn that off, and then you should see all this traffic come through into your proxy history. And now what we want to look for here is we want to look for a post request to the login URL. But I'm not seeing this, so maybe mine didn't capture. So let's just go ahead and resend the same user pass, remember me, sign in. Another quick edit. It looks like if you're getting this error, what you would need to do is refresh the cache of the page. So you're going to do Control-Shift-R, and then we are going to proceed. And then this will hang out for a minute. And now that the cache is refreshed, you should be able to make the same request as before, and the traffic should show up this time. Okay, so go ahead and try to make this request once again, and the login error that you should be seeing is invalid username and password. That means that the actual post request that's sending our credentials to the login endpoint that's evaluating if our credentials are true was sent, and we do see it in our HTTP history this time. So to actually play around with this request, we have it in our history and we can see what the request was that was made and then the actual response that we get from the application. But we want to be able to submit this same request over and over and over again and not have to deal with the front end of the application. To do that, we just want to make sure that this request is selected by clicking on it, and then we're going to do Control-R to send it to the repeater. And you'll see that the repeater tab up here gets highlighted. We want to navigate over there, and basically the repeater will let you send the same request to the application over and over again and manually manipulate certain pieces of information that are being sent over. Like we can edit the different headers, we can edit the actual post body data that's being sent, so on and so forth. And to actually exploit log4j, we need to be able to inject on any of these user input fields, which the headers are essentially user input fields, as well as all of the post body data that we want to inject on as well. Okay, and now I'm going to throw another quick edit in here really quick, where you can skip this if you feel comfortable understanding how log4j works, but I'm going to talk about some of the prerequisite technologies really quick that enable log4j to work as an exploit. So the first thing that we want to look at and just understand at a very basic level is expression language. And expression language is basically, you can think about it in the terms of this video and for the purpose of log4j as a variable in the Java programming language that you can use to execute inline commands. So what it'll typically look like, and I pulled up a terminal here just so you guys can see what it would look like, but you can see it's already kind of populating something, and it's similar in Bash. But you'll have this $sign and then a wrapping of curly braces. And essentially what that $sign and wrapping of curly braces does is allows the Java interpreter to read everything that's wrapped inside of this special syntax of $sign and curly braces and execute it as Java code with whatever is entered in there. And that, for the purposes of log4j, is basically all that you need to know. That's basically what that syntax is doing. Okay, and the next thing that you're going to see is the acronym JNDI. And JNDI is an acronym that stands for the Java Naming and Directory Interface. And that is essentially an API that's built into Java that allows it to make API calls to locate other resources or objects within a program. And basically, we're going to build out a little sample log4j payload here, but I want to build it out piece by piece just so you guys can understand exactly what each piece is doing. So what you'll see is you'll see that expression language syntax set up there, and then you'll see JNDI colon. And the JNDI in this case is going to be acting as essentially like a wrapper. And a wrapper is basically a way that tells a protocol how to handle the data that it's sending across. So the JNDI is going to act as a wrapper, let's say, in this case, and it's going to be responsible for locating other resources or objects within the program that this Java code will be executing in. Okay, and then the next piece of the puzzle is going to be LDAP, and you'll see it denoted like this. And LDAP is also an acronym that stands for the Lightweight Directory and Access Protocol. And one thing to note about LDAP is it's essentially this vendor-neutral authentication method that can integrate with directory services. So it used to be very commonly tied to, and I guess still is, with Active Directory. So that's what LDAP is, and it's basically going to be providing a lookup for the credentials on a network. And since it's looking authentication credentials up on a network, the next thing that you'll see is the actual IP address of the network or the target machine itself that it's doing the authentication on. So in our case, that's going to be the IP address of the machine. I'm just going to type IP address for the time being as a placeholder. And then after that, we need to specify what resource is being queried by LDAP. Now, in our case, this actually doesn't matter what you put here. So I'm just going to put garbage resource. And this is going to be a valid log4j-esque payload, not necessarily valid in the case that it's going to work, but the actual syntax here is what you're going to be seeing with all of these log4j payloads that we are going to be submitting from this point forward. But I hoped that helped break down exactly what the log4j payload is going to look like, because it does look a little bit scary if you don't necessarily know what expression language is, or what JNDI is, or what LDAP is. That all can add up very, very quickly. Okay, and so for the sake of brevity, we're going to quickly talk about why the log4j exploit works, and then we're also going to talk about how to identify a parameter that would be vulnerable to the log4j exploit. So essentially, the log4j exploit works because, as we saw, it's using expression language to evaluate code within its logging capabilities. So log4j is actually a logging package within Java. And as you could imagine, as I'm sending these post requests to this login endpoint, for security reasons and just optimization reasons, there's lots of reasons why you'd want to log traffic. But these applications want to be able to log where their traffic's coming from, and then they also want to log certain metadata associated with those requests. Like, for example, if I am checking this remember function, they might want to know when people wanted to have their login remembered for whatever period of time that they specified. That would be why the actual exploit would work itself. As you'll see, it's using that expression language to evaluate that, and that was enabled within the logging package. So when this request was being sent to the login endpoint would then write all the data that it found necessary to the log file, and then the log file was actually being parsed by the log4j package, and it would see this expression language syntax, and then it would have access to certain objects and processes where it could evaluate what was inside of the expression language syntax. That way, it could actually make a call back out to another system. And as you'll see here, as we begin to build this payload, what you'll see is that we are going to specify the JNDI, which is the Java Naming and Directory Interface. That is going to be the wrapper for LDAP, and these were all just protocols, objects that the log4j exploit vulnerability had access to. The next thing that we would want to do when building a payload for the log4j vulnerability would be to put in our own IP address. So you can check that up here in the top bar. Ours on this particular instance of the machine is going to be 10.10, 14.14, and then you can put in whatever garbage file or lookup you want. That's just going to be a negligible field that we can use. Now, in terms of identifying which parameter was vulnerable to the log4j vulnerability, the best way to do this wouldn't necessarily be to write these in one at a time. If you were actually trying to exploit this, you could put this in multiple places all at once, like the username, for example, the password. You could put it in this strict typing. You even saw that we changed the remember typing from a Boolean value to a string with our exploit in it. And that's because it's just simply an input field. And that is the same case for a lot of these headers here as well. These also could have been potentially injectable with this log4j vulnerability. However, I do know that this video is going to get a little bit longer, so I'm just going to go ahead and show you guys that this is the vulnerable parameter here. So we're just going to go ahead and set up this exploit, but what we want to do is we want to verify that the target machine is actually making an LDAP call back to our machine. And one way that we can do that is we're just going to open Wireshark. So we'll open Wireshark. We'll click on the ton0 interface because that's the interface that we're connected to on the VPN. So we will click on the ton0 interface. Then we're going to do tcp.port = 389. And that is because 389 is the port that LDAP operates on. And we want to capture any LDAP calls that are made out to our machine. So we'll apply that display filter by clicking on the ton interface. We are already started. You can see that by the red box being lit up. So it's listening for traffic that goes over port 389 to our machine, to and from our machine rather. And if this red box is not lit up, you could just simply start it up by clicking on this little fin icon, and then the red box should come up. That means that you're listening for the traffic. With that all configured, we can come back over to Burp Suite. With this payload configured in the request, we're going to go ahead and click send. You see we get an error, but that's pretty much to be expected. Then we can come back over to Wireshark. Now we see that there is some LDAP traffic that's happening between the target machine and our machine, and we can verify that by seeing the source address. So this is a packet coming to our machine. You can see that by the destination being the same as our own IP address, and then we are also making a call back acknowledging that LDAP query from our machine back to the target machine. And that would be verifying that this particular parameter is vulnerable to log4j because we submitted the request. That payload then got logged, and inside of that payload, that parameter that was holding our payload got logged, and then the payload itself was read as an expression language and interpreted by the Java interpreter, and then it made the necessary call to reach back out to our machine. And now that we've verified that that parameter is in fact vulnerable to log4j, what we need to do now is we need to install a handful of packages that are going to help us build out a proper exploit. That way we can execute some malicious code on the target server with these LDAP calls. What we can do, we can get rid of that Wireshark window. We're going to need a new terminal, and we can get rid of this proof of concept log4j exploit there. The newest version of JDK, which at this time should be 11. I believe that's what is required for this one to work. But before we even do that, what you typically want to do is you want to update your repositories. So I'm just going to go ahead and update my repositories really quick, and then we'll move on to actually installing that package. Okay, now that the apt repositories are updated, what we can go ahead and do is we're going to do sudo, actually let me bring this up to the top so you guys can see what's going on here. We're going to do sudo apt install open JDK 11-JDK, and then we're going to hit enter. This is going to install the Java developer kit for version 11, which is what is required for this repository that we're going to be setting up. Go ahead and let this install, and then we'll cut back over with the next package. Okay, that just finished installing. We do want to verify that it has been added to path correctly. So what you can do is java ---- version, and we should see OpenJDK 11. So now that we verified that, the next package that we're going to need is Maven. And to get that, we're going to do sudo apt get install. And then what we're going to do is just type in Maven, hit enter, and then we will install Maven. Okay, so that installed all properly, and we should be good to go there. Okay, so this installed and we should be good to go there. Just a quick background as to what we just installed. The JDK 11 is the Java Development Kit version 11. That is basically going to help us build jar files, which are Java applications. Maven, on the other hand, is an IDE, which is an integrated development environment, and that will basically help us compile that Java code that we write, or that is required in a pre-built repository, and we can compile already written Java code. The last thing that we will be installing for now is we want to clone down the Git repository from Veracode that has created a LDAP server. It's called Rogue JNDI, and it's going to basically spin up a malicious LDAP server such that we can receive those LDAP queries from the target machine, and we can then execute malicious code on the target machine. So to do that, all you're going to do is git clone, and then I'm going to paste the URL in. You guys can take a look at it here really quick. You could pause the screen if you want to copy. If not, I'll link it down in the description below, but it's just going to be https github.com and then veracode-research and then rogue-jndi, and then we can just go ahead and hit enter, and then all we need to do is cd into this rogue JNDI, and we have all of the source code copied down for this repository that we will be using for the attack. Okay, and now that we are inside of this Git repository, we want to run the command mvn and then package. And basically what this is going to do is create a jar file or a Java application that's capable of sending our log4j payloads to the target, and then it'll basically just be a medium for us to use to write malicious code to the machine, and it'll basically just be responsible for us sending a reverse shell and then it handling it in the meantime. So you see we have the build success there, and then if we do ls, you can see we now have a target directory. So if we cd into target, we should be able to see that we have a jar file now. So we have this rogue JNDI jar. That is going to be our Java application that we are going to use. However, first we need to actually build out a reverse shell. Quick little tidbit here. We know that we're attacking a Linux machine. So one tool that you can always use, Netcat's pretty standard for getting reverse shells, but Netcat isn't going to be installed on every single system that you attack. Whereas you can use dev TCP and essentially at a super high level just pipe bash into it. So we can have dev TCP send an interactive bash session back to us, but I'm going to go ahead and also cat the command out just so you can see what it would kind of look like. So what we need to do is I'm going to grab all the way up until here, but we are going to do echo, and then we're going to paste dev TCP, and then we need to enter our IP address on the ton interface, which is shown conveniently in Kali right up top. So we'll do 1010 and then 1414, and then we're going to do / and then we just need to specify a port. I like using port 9001, doesn't necessarily matter. So then we're just going to add the final portion of this payload, just going to add that. And now all that we need to do is, this is going to echo that statement. What we need to do is we need to pipe that contents of our reverse shell that we just created, that little reverse shell payload, to base 64. But basically what this is going to do, different protocols encode things differently. As you've probably seen in the past, just like we saw actually at the start with the Nmap scan, HTTP will URL encode data, and certain characters can get messed up. However, if it's pre-encoded to a format like base64, we can avoid running into any troubles with the payload getting its characters messed up. So we pipe that to base64. We now have this base64 encoded string, which when decoded will decode to our reverse shell. Just like I did before, I pre-recorded the command that we're going to need to pass to our actual target application because it's going to take a second to break down. So we have that noted down. I am just going to go ahead and copy our base64 encoded string. So we will go ahead, copy that, and now we need to go back over to the rogue JNDI, and we'll even go into the target directory. So we're in the same directory, and now all that we need to do is we can do cat that app command. Okay, so now that we're there, we can see that we're basically just going to run Java. We're going to do tag jar, which basically tells Java to execute the provided jar file. In this case, we don't need to do target / that whole thing because we're already in the same directory as the target jar file. You can start typing rogue and it will autocomplete for you. Then we need to pass the command to this jar application, and we do that with -- command. Now, we are going to close everything inside of double quotes to begin with, and we're going to start out by typing bash c. Bash C is basically what you would use to execute inline bash. So now what we need to do is we need to add some curly braces, and we can do echo. We're going to add our base64 encoded string payload. So once again, that's going to echo, you're just following along, that's going to echo our reverse shell, and then we just need to add a pipe character. So we're echoing our reverse shell that's base64 encoded, then we're going to pipe it to what is in these next set of curly braces, which is going to be the base64 command, and then we are going to follow that up with -d, and that is essentially going to handled the decoding of our base64 encoded payload. Now that we have a base64 decoded payload in this inline bash command, we are going to pipe that to our next command, which is going to be bash, -i. And -i for the argument in bash is actually going to be a interactive shell. So we're piping our payload to an interactive shell, which is awesome, because then we'll be able to have some sort of stability and persistent access to the target with that command. And then all we need to do is -- hostname, and then we just have to add a couple more quotation marks here, and that is just going to go inside of some curly braces, and then we just need to add our ton0 IP address, which is the one that's noted in the top bar of Kali once again. So now that we have this completely set up, we should be able to run this application. This will spin up a malicious LDAP server on our machine, and then it will handle the process of sending that reverse shell to the target system and then send us back a reverse shell so that we can have some sort of persistent access there. Quick edit before we go ahead and run this command. I did realize that I was using these curly braces as placeholders. Don't actually put your IP address in curly braces. It just needs to go in quotation marks after the hostname flag. Another quick edit, make sure that you spell command correctly, as I did not here. However, if we go ahead and run this, what we'll see is that we have our malicious LDAP server spun up. So that's all good to go for us. It's basically sitting here waiting and listening for us. So now all that we need to do is go back and change our payload in Burp Suite to this LDAP query instead instead of the original LDAP query that we provided. So what we can do is we can go ahead and grab this LDAP query. We can just go ahead and copy that. And then we need to set up a reverse shell listener for us. So what we can do is just open a new terminal tab, type in sudo lvnp. L is to listen, V is for a little bit more verbosity, N is to stop DNS name resolution, P is going to specify the port, and we need it to be the same port as our reverse shell, which I put as 9001. It might be different for you. So we will go ahead and start that listener. We have that listening, and now we should still have that payload configured. So all we need to do now is take what we previously had for this LDAP query and paste it in here. We do not want this end piece as we have it mapped to O-Tomcat. You want to make sure that the syntax is correct here. We can go ahead and we will send this request to the server. We are going to get a 400 error again, but that does not mean that it did not work, because you saw we got 400s before and it was sending the request. So let's go ahead and we will pipe back over to here. We can see that we got this sending LDAP resource ref result for the O equals Tomcat payload. So we're hoping that that is going to essentially just process what we threw in as our payload, and then it will execute our reverse shell and send a connection back to us. Okay, so mine took a second, but it did end up connecting back here. And now we see that we have a very primitive reverse shell on the machine. One thing that we can do to upgrade it is do script, and then we'll run this on dev null, which is essentially just a black hole on the system. And then all we need to do is -c bash. And now we have a stable, more stable machine or reverse shell on the system, and we can do things like do ls, look around for things. We can go back a directory and look around in there, see what we have on the system. We can even go all the way back to the root directory and see if there are other users on the system by going to cd to home and ls. It looks like there's a Michael user on the system. Let's see if we can access Michael's directory rather, and we can, and this is where we are going to get the user flag. So I will cat out the user dot text. And boom, there is the initial foothold on the unified box. This is how you would do it. We, from here, will be talking about how to do the local privilege escalation. So going from a standard user up to a root user on the machine. Alright, so funny story, my footage actually corrupted for this part of the video, so I had to reshoot this, and in the meantime I actually completely redid all of the setup around me. So new lighting, we got some cool lighting going on. We actually have a little bit of an upgraded camera, so hopefully the audio quality is a little bit better, and I made some upgrades to the mic as well. But let's jump right over into the privilege escalation walkthrough. I'm actually going to withhold from explaining how to get linps up on this system and then running linps, because I've shown that multiple times before, and this is going to get kind of long in terms of the length of this video, and I don't want it to be too long. So what I'm going to do is I'm just going to show you the actual piece that we are going to use to privilege escalate through this machine. So if you were to run linps, you would find out that there is MongoDB on this machine. That's what is harboring the credentials and acting as the database for the web application that we saw, that Unify management application that we used to get OS command injection via the log4j exploit. Now, if you did a quick Google of MongoDB, and I always like to do a quick Google, we did it with the Unify software, you'll find out that the default username is Ace. So one thing that you can do is you can use the command line tool Mongo and then we can just do mongo -- port. And if you do see it on the nmap port when we ran the full scan, you'll see that the port is going to be 27117. And now that is just the port that we're going to specify, but then we need to specify the username. And the default admin username is Ace, so we're going to specify that username. And then I am going to do --eval. And --eval is actually a way to run code, so to say. But what we're specifically interested in doing is using this method. And we're going to call it on DB, so we're using the database object, and then dot, the object underneath that is admin. And then that admin subclass actually has a method that you can call on it. And that is going to be just a find method. So we're going to try to find something, but we need to call an additional method on this find to sort our information a little bit. And it actually has a built-in for each function, which is essentially just like a for loop, so you can iterate over every admin in the database. And then you just need to use this print JSON. Whoops, and that does not have a capital J before I enter that incorrectly. And then you just finish it off with a semicolon, and it is finished. So just to quickly recap, we are accessing this database, or the DB or database object, and then we are accessing the admin sub object in there, and then we're using the find method on the admins of the database, and then we're going to iterate over all of those, and this is pretty much just going to sort it and print them as JSON, because that's kind of how MongoDB stores its information. So if we run this, we should get a list of all of the users on the database that are admins. Now, if you scroll all the way up to the top, you'll see that we do get the administrator user. We have the email, and then we also have this X shadow, and the X shadow is going to be the admin's password hash. And if you'll note at the very front of this password hash, you usually have these signifiers at the beginning, and $6 actually signifies a SHA-512, which I believe is the default for this database setup. And SHA-512 is going to be very difficult to crack just in terms of the complexity of the hashing algorithm. And we don't have the time to sit around and crack this. I'm not even sure if you can, but there is a path outside of cracking this password. So in the sake of not spending 80 years trying to crack this password or something ridiculous, we're just going to use another type of exploit that we know of. What that is we can use this make password utility, and pretty much what we can do is we can overwrite this X shadow hash with our own version of the hash. So what we'll go ahead and do is we're just going to come all the way down here, and you can see too here, just as a quick verification, all of these are showing $6, so it looks like all of them are going to be SHA-512 hashed. So not going to be a ton of luck. I think that's just default across the database. So what we want to do with the make password command is we're going to do mkpasswd, kind of like my username for the password, and then we're going to do dash or tag m, and then we're going to do SHA-512 to specify the, whoops, I just realized I typed that in wrong. We're going to do SHA-512, and that's going to specify the hashing algorithm. And then all we want to do is generate, we're pretty much just going to generate a hash for this new password that we generate. But to do that, we actually need to enter a new password. So my new password, I like to keep things simple, and I'd also like to try to keep the password complexity to some general statements. Some places will not hash it if it doesn't meet the password complexity requirements. So we're just going to create a password that is up to par with a very basic complexity. So what we'll do is we'll just do like a capital P, I guess, for password. And then I just do like the number 1 and an exclamation point. And that pretty much hits uppercase, lowercase, 8 characters, a number, and we have a special character. So we should be good to go in terms of complexity there. totally forgot to check and see if the Michael user even had the make password utility. He doesn't, so let's just go ahead and paste that utility on a local command line, then we'll just copy and paste back over. I just switched over to another terminal tab. We'll just run that. You can see if we generate this hash with the SHA-512 hashing algorithm, it is also going to generate that $6, so the format is consistent. We will go ahead and copy that hash. So we're going to take that, and now we're going to try to overwrite that X shadow for the administrator user. One thing to note before we overwrite this X shadow attribute is we want to grab this object ID. This is essentially how the objects are denoted in MongoDB, and this is how they're found. So do yourself a favor and copy this down real quick. Okay, so let's go ahead and update that X shadow with our newly generated password. So just like we did before, we're going to use that Mongo keyword. We're going to do --port 27117 is where this one was located. Ace is the default username, and then we're going to use that eval once again to run a command. Just like before, we're going to use that database object, and then we're going to do .admin. We're going to do update this time. So we're going to be calling the update function on the entry for the X shadow password hash for that Ace user. So to do that, we actually need the object ID. If you don't have it, you need to go grab that all the way up at the top of the results. I copied mine down, so I'm just going to grab that really quick. But we want to make sure it's denoted as JSON, and I don't think I copied it down as JSON, so I'm just going to manually type this in. So we have an open curly brace, and then I believe it was denoted as _ID, and then we just need to do the key value pair, and then we just need the other portion of this value. So we'll just go ahead and we will paste in that object ID. So you'll see it just denoted just like that. Then we're going to close that curly brace, and that curly brace is actually going to be that first JSON pair. So we'll put the comma because that is where we are trying to update at. That's retrieving the object that we want to update. Then we want to pass it this second argument here, which is going to be another JSON object, but we need to use a built-in type of functionality where we can set a key value pair. And the key value pair that we want to set is that X shadow password hash with our new hash. That way, when we authenticate with our new weak password, we can just bypass authentication. So to do that, all we need to do is we need to do $set, and then we are going to do the colon, and then we need to pass in the actual JSON object that we want this time. And to do that, we do that open curly brace to start, and then we need the identifier, which is going to be the X _ shadow key, and that is accompanied by the hash of the new hash that we generated. So I need to grab that. We will come back over here, grab that, and then paste that in. And then we want to close that off with a double quote, and then we need to finish closing off all of our open curly braces and parentheses. So if you look back, that's going to be the closer for this JSON object right there, but we also called the set on this key value pair, so we need to close that one off, and that one is going to correspond with this one right here. And then if you were still paying attention, we also needed to close off the function call, and that is going to be done with that closing parentheses right there. So then we'll just do that, and then we also need to close off our last quotation mark, and that would be everything that was inside of this eval statement. So when we run this, this is going to update the administrator user's password hash. So I accidentally clicked Control-C, which killed the reverse shell. So all of that, the Control-C, horrible occurrence. Very sad. So now I'm just going to show you guys, please make sure that you use single quotations. It's going to make everything be interpreted as a literal. If not, you're going to run into a bunch of issues with formatting strings. You don't want that because this shell is not exactly stable. It's slightly more stable than it could be, but it is what it is. So we go ahead and we hit that. We did have one insertion modified, which means that we now have an updated administrator hash. So I think our hash is pretty indicative by these like 2 random backslashes here. So if we just rerun that first command that we did, which was just mongo -- port 27117 ace, and then we just do -- eval, and then we just we'll do db.admin.find, and then we do for each, and then actually I think each needs to be capitalized, and then we just do print JSON inside, and then we close that off. We should see this administrator user all the way at the top here. Sorry, this returns so much. We should see it with our password hash now, which we do. So now we can go ahead and bypass the authentication into the administration management site, and then we can hopefully get some credentials from there. Okay, so now if we come back over to this administrator interface, all that we should have to do is go to the administrator user and then type in the clear text password of what we hashed and updated, which was password1 with a capital P and an exclamation mark at the end. That is kind of what the deal was. We hit enter. It looks like it liked that, and boom. Look at that. We have access to the administrator interface just by updating the password hash. So now all we need to do is try to see what we can grab off of this site. And I'm going to make this a little bit of a spoiler. You can dig around here if you want to try to see if you can find some passwords. I know where the credentials are at in this case, and I don't want to drag this along of me just digging around a website. So all you need to do is you need to go over to the settings, which is located down here at the bottom left. You can click on the settings, and then from the settings you go into the site, and then on the site there is SSH authentication credentials, which are located right at the bottom here. So you see this device authentication, we see it has SSH enabled, and they're authenticating to it as root. Now they have the password here, and there's actually an unhide function here. So it looks like the password is not crackable password for you 2022. So we will just go ahead and copy that password. Then if we come over into a new terminal, hit Control-Shift-T for a new terminal, and then we just SSH. Let's grab the IP address of the target here, and then we'll just come back over, and then we'll do root at that, and then we'll just say yes, and then the password of that guy was right here. Let's just copy the password and then come back and paste it in, and we are now root on the unified machine. So if we just ls and then cat out the root.txt file, we have the root credentials, and that is how you go through the entirety of the unified machine on HackTheBox. Apologies for this video getting a little bit long, guys, but I really wanted to take the chance to take a deep dive into Log4j and some of the other impacts and the technologies that get behind it, because Log4j is so new in this space that there's not a lot of great information out there. There's a couple of good tutorials on it, but I don't see a lot of things really explaining why certain technologies build upon each other and why the payloads look like they do. I know 6-7 months ago when I saw Log4j payload, it just looked like a bunch of curly braces and dollar signs, and I thought somebody was crazy and threw them together. and it just happened to do something. So I wanted to break that down and make it digestible, and hopefully you have some actionable takeaways from this. Also, I'm going to throw a bunch of resources down in the description below if you want to read up further. Another quick thing too, I've had some troubles with releasing a lot of this offensive security content on YouTube, and they have been content striking me a couple times now and demonetizing some of my videos. So if you do want to leave a like or continue to subscribe, share the channel, share the video, it does help in the appeal process and it does help me out. I do want to get this information out there, but it's pretty difficult when YouTube decides to content strike it down. So I appreciate all the love and the support so far, and I will catch you guys in the next walkthrough.